live. So we're live
Alrighty.
now.
Yep. Let
We're
me
live
double
now.
check.
Testing 3, 4, 5. Had camera issues, had button issues. That's going to screw up the playlist, right? Or this is the same one.
Same one. I can remove the other, like the empty video. I can remove all
Okay.
that.
All
No
right.
worries.
Had a
We're
bunch
good
of
now.
Bill made mistakes not looking at which link to go live with, and took over. I guess Herbert's doing a Rust thing today. Is that what's happening?
I don't know if it's today,
All right.
but it is upcoming.
So now I have to look at that list instead of just blindly say go live, like I've been doing for the last 2 months. So we missed our intro music. We missed our little banter, but that's fine. I said I had a hard stop at 1300, so we really got to sort of get going here. I had camera issues too, but looks like camera issues are resolved. All right. So as we were saying before, but now we're on an actual live stream. Delaney's going to join us on Tuesday to write the Data Star client. We've got to figure out how we do that while he's driving, because he's going to need to drive that. So I guess he'll, I'll have to figure that out. So we can see his big screen like this, right?
Mm-hmm.
You might have to get with him on Monday or something. I don't know. The last thing we want to do is fight through that the half an hour before the show. So figure that out.
Agreed.
We finished Tuesday with sharing our public key across. So if you and I both look at our client database, we now see public key. We did that with what? The /share key command, right?
Yes.
Okay. So now we've got a public key locked in here. And we need to double check that on startup. Again, it's front end stuff here. That on startup main, that we're also loading the key, right? Just want to make sure that. Okay, I feel like new database, contacts, go through the contacts, my account, contacts, and new DB, I imagine, is doing all this, reads it from disk. Yeah, and from read on disk, we decode the entire data file user. So key. All right, so my guess is the key should be there. Okay, great. So I think the next thing for us to do, at least today, is really, should have made this here, but so here we got to implement the actual encryption, right? If a key exists. So if you have my public key, then you should be sending that message in an encrypted state. Now, question is, how will I know that the message is actually encrypted as opposed to not encrypted, right?
Mm-hmm.
So I want to look at the data models again. So this is an outgoing message, right?
Yes.
And it's just a message with a string. And then the incoming message is a message with the string. So we're not going to know necessarily if the message is encrypted or not. So we've got a couple of choices here. We could add another field that says encrypted. And then if it is, we do that logic. Or we could prepend a marker of some sort to the front of the message, right? That says that it's encrypted.
Would this marker be available like in the actual chat window, or it's just something we would have?
It would be behind the scenes, right?
I got
It
it.
would be behind the scenes. So it could be some sort of marker that you couldn't type in yourself, obviously. It could be as simple as byte 0 that says, right? Byte 0 that says that you've got this message is encrypted and it should be dealt with appropriately in that way. Okay, so somebody's saying,
Okay.
hello, Bill. The event link sent to another video, not this live. So,
Yeah, they're working on it.
oh, so we're not live right now?
We are.
But
Just
it wasn't,
we made the new session now to be able to go live.
yeah.
Because the other one went out of upcoming, so they're updating that now.
That was totally my mistake because I hit the button and got scared. I hit the wrong button again, and then I ended it. And I shouldn't have ended it. So that was Bill being flustered and using the wrong link. So bad Bill. It's kind of the way the morning's been going. So why not? Okay, so we could do both, right? We could have an encrypted sort of field with the message or not. So, or we have to parse the message out. So what do you think is the best sort of way to do this, Kevin?
I don't mind the marker. I don't mind the marker. And then the other option was to do a field, right? That would tell us whether, like, true, it's encrypted, false, it's
Yeah, so
not
something
encrypted.
like oh, I can't spell either. Encrypted, Boolean, right? Jason and would help if I do this. So doing something like that.
I think
doing
I like
something
that
like
better.
Yeah, I mean that would work, right? By default,
Yeah.
it's false. So I always like that the default is that false in these cases is the common sort of place to start. But if you did this, we'll have to change the cap side also, right? To
It would have to follow that.
Right, it would have to be the same. So on this side, the incoming message, we haven't coded any of this yet, but always start with the data.
Yeah.
If you get the data structures right, everything else is fairly obvious after that. So you've got the outgoing message, right? So that was, right? So we do that, then we have that. The data that we're going to be signing will have that encrypted data in it too. So that's fine. I think we have to look at that. So now, how do we know where this is being used? So this is where I love Go's compiler being so damn fast, because I'm just going to do that, and things are going to go red, right?
Yep.
And when I do that, it goes red down here. So if you notice that we're signing this, the message, the nonce. So the question is, do we want to add the encryption to the data that's being signed? I don't think we necessarily need to. I don't think we
I
need
don't
to,
think
right?
so either, because isn't that kind of like being hidden in its own way through the
I don't think it adds any value, right, to what we're doing here. It doesn't make it any better or worse, right? But this message here, now we're going to have to do it in the pre-process because we don't want to encrypt a command, right? So if message does not equal this, then return it, right? But so we're going to have to do it in this right now. Now the question though is, we need to know who we're sending it to in order to get their private key. I mean the public key to know what's going on.
So we have to know, okay, we have to know who we're sending the message to then
So
get
let's
that.
come back here for a second. We know who we're sending it to, right? It's
Yep.
this right here.
Yep. That
So
address.
what if we do this, okay? We bring this in. But now what happens? I need access to the user from the database, right?
Mm-hmm.
Did we already did it. Look.
The query contact by ID.
So honestly, we don't want to send two. We want to send what?
The user.
We already got it. There's no reason to do another database. That makes me feel really good too, that we already hit the database. It makes me feel like we're like on the right path here. So now we know. Go on.
So pre-process is getting the gorilla in this case.
But it's fine because we know the gorilla's holding the banana because we've queried it out of the database, right?
Got
And
it.
you can always write APIs that take a gorilla if you got that 100%. We have it. We saw the query call. So,
Yeah.
I think the API is cleaner this way. And sometimes when you have an API like this too, it's forcing them to go pull the gorilla, right? Because if they create a partial gorilla, then you're really bad. Like we can see that, right? You're manually trying to do something. Here, it's almost sometimes an API like this asking for the gorilla is like, hey, dude, you got to go to the database and get this because this is what we need. It gives us a better guarantee on the integrity. So what we now want to do is look at the key and let's say if this key equals this, then we can just return this because there's no encryption going on. We don't have a key.
Okay.
Now, here's another problem before I finish this. We've got the key in the PEM format. But remember, we got to convert the PEM format to an actual public key in order to leverage the APIs. So
okay.
Let's go back to the model for a second. I need the user itself, actually. Let's go back here for a second. Where's this user type? Okay, here's the user type. And this is an app. And you can see we have the key here. And you can see that we have the ability to update. We have the ability to query. Everything's at the user level. But I'm wondering if this really shouldn't be the string. It should be a pointer to an RSA.public key. Because that's what we need, right?
Yeah,
That's what
at
we
the end
need.
of the day, that.
I mean, that's what we need. And so if that's what we need, all right, and I come back here, we went through here and did this, which was fine. But now what I think we need to do is say if user.key, actually, we're going to do this. We're going to create a little variable here called public key, which will be a pointer to an RSA public key. All right, and then whatever that is will get assigned here, which could be nil. Now, if the user key isn't equal to this, now we have to write, now we need that code that converts the PEM over to, and that's a little bit of code that we had to write. Now, if we go back to our hack program, where's our hack program? Under tooling, hack. That's going to be, well, we never actually wrote that code because we didn't need it. So what I'm going to do is go back to the service project. I'm going to go back into the toolbox, all right?
Yep.
Let's go back into the toolbox. I'm going to go to tooling, admin, commands. Let's see, the gen key only does the private side, right? Let's
or
see.
public.
Does it do both?
I saw public at the bottom.
Oh, here it is right here. Okay, perfect.
Yep.
So I'm going to steal this code. Oh, no, but that writes the public key. So that's not what we need. I need to take the public. I need to read the public and convert it back into a public RSA.public, right? Now, all this code that I have here, though, maybe I have it here under key store. But see, I'm always playing with the private key here. Oh, but we wrote the private key, didn't we? We have a private key at the end of the day. We don't have a public key.
Yes.
Look, let's go back to this for a second. What we are writing under here is the private. Yeah, that's the private key. That's what we have. So, oh, but we need both. Okay, hold on a second. We're going to need both the private and the public because we, on the other side, we've got to decrypt. So,
Oh, yes.
yeah. So we essentially need both. We need public key. We need, oh, but a user only has a public key in our case here. So here's the problem, all right, before I get any more confused. I have your public key. I have it in a PEM format. I need to take that PEM file. So let's see how we do it with decode. We'll find the next PEM. So maybe we can just use this decode. Oh, look, to public PEM, giving a private. But let's see something here. Honestly, this decode should work for both the private and the public, I would think. Decode will find the next PEM formatted block. It will return the block and the remaining input. If no PEM data is found, P. Okay? So let's just take a look at that for a minute. So we decode the PEM. Now, I know this isn't a private key. I know this is a public key, right?
Yes.
But normally what would happen is I have the block bytes. I've never actually parsed the public key before, so this will be interesting. Let's take a look at this for a second. But instead of private, maybe there's a public. All right, save you for a second. Parse, parse PK1 public key.
Public key.
PK1S1, PK1S1. So I think that's good. That should work. We'll try it. That returns the RSA public key that we need, right? Look what I did with I didn't need that.
It would return the public key or the private key?
This returns the public key that we need. This isn't about private.
Oh, okay.
I have in the database your public PEM. So I'm trying to decode that. I'm decoding it, and then I'm trying to get back to this RSA public key, which essentially what this now means is if error doesn't equal nil, then I can just say this equals this, right?
Got it. Okay.
And then RSA public key. Didn't I say this is RSA public key? Oh, we called it public key. Sorry. So this could work because when we did the creation of the key, right? Wherever we did that, it'd be nice to find that code. On startup, let's go back to startup. Come on, Bill. Sorry. New app layer, right? App layer.
Yep.
And we say create ID, and then we said create, right?
Yep.
We're using that same PKS1 stuff. Okay. So I think that's going to be fine. Now, what I don't like, so what's got me concerned now is okay, what's got me concerned is this a application layer concern? Because if I don't use, I'm also worried about updating You see how we need both because we got to write it back to disk the way we work. So there's a couple of problems here. We write that back to disk exactly. Now, see, even this is bad, dude, because this is what we're writing to disk, right? We've mixed, but then again, we didn't because we're implementing an interface, right? At the end of the day, we're implementing an interface. So I have So I have a feeling if I go back to our user here.
We still have that X message up there too.
Yeah, I know. I think that, what did we call this? What was this called originally? I'm going to undo all the changes for a minute. We didn't really change much, did we? That was key.
It was a
string. Okay, I'm not going to change. Okay, this is what I wanted to see. Key string, right? So So I think that this code that we added here can't be done here. Let me steal this. I think if we do that, we're mixing concerns.
Okay.
Now, what I'm confused about is that just don't save that change. Okay. We're mixing concerns, dude. This DB file shouldn't care what type of key it is, in other words, okay? So
okay, it should just know that it needs a key.
That the key is a string.
Yeah.
Like what type of key it is should be irrelevant. Now, we are serializing this object, okay? But if I make this unexported, then that won't get serialized when we actually write everything to disk. Because when we flush to disk, we're going to convert that to, we convert that to JSON. See?
Gotcha.
Which is fine.
Okay.
So I think what we have to do is the conversion up here. I don't want to do it at the storage level. This is an app layer concern. We know that it's an RSA public key at the end of the day, but what if somebody wants to use, I don't know, whatever else is out there, right? I think it's too strong of a policy to suggest that, right? Because even the code that we've written right now at the app layer, it's all app layer concern, like what we're doing here.
Yes.
It's not disk related. So, even when we start up and we create the key, we create that private key. If I go back to main, it's at what? It's at the app layer side, right?
Yeah.
It's at the app layer side. And when here it is right here, right? Create the key. And then the command that we wrote to do the send, forget about this for a second.
Preprocess send.
Here.
Yep.
Right? This is where we're sending our own app ID, right? And this is in the ID stuff. So the fact that we called it an RSA key and we have our private key here, that's an app layer concern. That's fine. But the moment we start using the word RSA in the storage layer, right? Let's say Delaney
we're
doesn't want to
getting
use
to
RSA keys. Delaney wants to use sort of something else, right? Then
we're being too strict at that level.
we're just mixing. We're mixing a concern that should be an application level concern, not a storage level concern. This is a mistake that's made all the time. This is what starts making code like super glued together. All right. And
I see
so
it.
we've got the glue is already the type. So we've got the user type. But if we make this unexported, then we're going to be able to control sort of what that key is. Now, what happens though is anytime that we get anything back from storage, we're just going to have the PEM. All right. So that's a bummer to me because anytime we get anything back from storage, all we're going to have is the PEM. Now, we could decide to be inefficient and write a function that, given this PEM, just does the bytes to convert it. We could be a little bit more efficient and create another sort of data structure, which would be a map of, say, ID and public key if it already exists. All right, so let's do this first. I'm going to get rid of this. Okay, let's get rid of this. And I had code that I just got rid of, but I think we can write it again. So let's go and add, I just need a function for a second. All right. Let's be inefficient right now, just to do it, right? So some function called maybe get public key, right? Where given a PEM returns an RSA public key. And potentially an error because that might not work, right? And then we go back and I steal this code again. Okay. And then we go back and we steal the X509 dot parse PKS1 where it gets a block. And that should have worked. Didn't that compile the last time? Slice of bytes. Oh, that's a PEM block. Oh, sorry, dot bytes. Okay.
Ah, okay.
And then this gives us the public key or an error. I know I misspelled that.
Yep.
If error not equals nil, return, sorry, nil. Fumped dot error f, right?
Parse public key.
Yeah, we could just say parse public key, right? %w error. If not, then return public key nil. So we could just do this every single time, right? Just a little inefficient. We can make it less inefficient at some point. But by doing that, okay, what that would mean now is we just use this function as we need it. So if I come back to the, I did this purposely so I could find where we were using it, right? Which was here.
Yep.
So we were in pre-processed message, right?
Yes.
So at this point, we know we have a key. So we could use that function, user key. That gets us back the public key and or an error. If there's an error, then what do? We return, like, we don't want to return the message. We do need to return an error, right? it was unable to encrypt message, right? And now that we've got the public key, let's call it public key. Now if I go back to my hack program,
Encrypt. Yep.
encrypt the data, right?
Yep.
And then this is your message. Fine.
Message. Yep.
And then what we do is return the data that way. This is more unable to read the public key, right?
Yeah.
So you can see I like this pre-process because we're able to sort of hide this sort of stuff here, right? Now it's about anywhere this is being used, right? This just pre-processes the message. Everything else just works sort of out of the box there, doesn't it? Like nothing
Yes.
changes.
It's all.
That's when I sort of love pre-process. That's when I love these little functions because everything after it works the same regardless of what we've done to the message, right?
It's self-contained for the most
Itself,
part.
like all the right. And now the logic before and after it is all the same. It's just a matter of how we're going to manipulate what we're sending.
Right. We
And
just
so,
manipulated the data a little bit.
yeah, so if it's not a command, okay, and there's no key, then just use the message. Else, what we're going to do is convert the key that we have to a public key, encrypt it, and then we send the encrypted data. And we can make this a little bit more efficient over time, but let's look. And if not, then we know these are commands, right?
Got it. Okay. So that's essentially what we just did. Is if it's not a command, it's just a normal message. It's gonna do the encryption.
Yeah.
And send that on its way. Okay.
Right? Process normal message or process commands. Again, like over time, we can, if a function starts to get a little too big, we could break it up in another function. But I don't want to do that sort of right away because right now we don't need to. This is still fairly small and we can see what we're doing. This is essentially just use the message or encrypt it versus right now we only have the one command. But over time, I could see us sort of taking this code and breaking it up into some more functions.
Mm-hmm.
But like it'd be premature to do that right now. It'd be premature. The moment we have a second command, maybe.
That's maybe when it's time.
Maybe when we have to do another thing in here. Maybe, right? So what this just did is it gave us the ability now to encrypt. We did it right. So that's on the pre-process send from the client. Bop. Now, what's going to happen now is if we receive a message.
Yes,
'Cause
which
that's
we
on the
already have
sending
a.
side, right? Oh, we have
Yeah.
a problem though. Oh, we have a problem, young man. You
Oh.
see, we added the encrypted. So what we're going to need to do is,
Oh, because now it could be a regular message or an encrypted message.
yeah, we don't know if we've encrypted it unless we're here, right? So false, 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 true, right?
Yeah.
So now we need to know if we've encrypted it or not. And we need that in order to set encrypted here. Encrypted was a bool, undefined, because now we've got a new variable. Okay. All right, so now we know whether or not we've encrypted it, right?
Yeah.
Okay, great. So that's on the send side. Now we've got the receive side that we've got to deal with. Okay. And again, we did add encrypted here. So this to me is just a pass-through. It's just a pass-through at the end of the day. Let me see what happens on the cap side before we do the next thing. So that doesn't change, right? We're not going to change what is being signed. That doesn't change.
Nope.
Listen bus, data that was signed, that doesn't change. But, and that doesn't change. But we do have to transfer over this encrypted field or it won't get passed around, right?
Yes.
So
And incoming message.
listen bus, this is when the cap receives a message off of Jetstream. We validated its signature. We retrieved the user. We've said who it's from. Kevin, I just lost you, bro. All right, I just lost Kevin. We're always having technical problems lately. Oh, Kevin's back. Oh, shoot. I lost Kevin again. This eCam software is not fun. He's going to have to dial in again. Dial in again. Now I'm getting messages from Kevin on other channels. Yeah, lost it. Lost it, dude. Okay, let's see if I can get Kevin to dial in again. Sometimes if I hit the wrong button on the eCam and I don't see the... There it is. There it is. We'll get Kevin back in here. All right.
There we are.
Dude. All right. So I think the problem's going to be here in send message. See? Outgoing.
Okay.
Outgoing message. Remember on the cap, and it's an outgoing message, but send message on the bus has the incoming. Oh, I think we're getting it for free. Okay. Oh, we're going to get it for free. Because we're just going to take the incoming message and send it out, I think. Interesting. Okay. I see. Outgoing message. Let me see what goes right here for a minute. On the outgoing message, yeah, now this is where we're missing it. We don't have the encrypted anymore.
On the outgoing. Okay.
Yeah, that's line 356. So if I do this, go back to line 356, we're not setting encrypted. I'm setting from encrypted, and we're going to have to pass that in. That's going to have to be there. That's going to cause you to say what? So bus message, incoming message from nonce, bus message dot encrypted.
Encrypted. Yep.
Bus message. Yeah, I don't know. Everything just sort of promotes up, so I shouldn't have needed that there. And then here, it's the same thing. So now I'm wondering, so I'm using now 3 fields from the in message, right?
Mm-hmm. Yep.
But this send message uses in message. Oh, and that uses bus message. See, I can't use a gorilla here because the data that we need comes from two different types, right?
Yeah.
So we have to do it this way. From encrypted that, here's our, we can set encrypted. And then same thing, sort of send message bus, but send message here, encrypted. Now, from send message bus, we already have the incoming message, which already has encrypted.
Has encrypted in it. Yeah.
So it just goes. So this is the problem when we were sending the message back to the client, right? I don't know why we didn't, because this is when we write back to the socket, which is what we've been calling the client, right? I don't know why we didn't make that change. So you've got send message back to the client or send message to the bus. And so we're just going to have to make sure that we set encrypted there. So I think these are all the cap changes. But now we have to deal with when the message comes in. And I think
so now we have the pre-process.
Here, receive a cap message.
Oh, okay. Receive cap message.
Right?
Pre-process, receive message there.
There we go. Okay.
Yep.
So it might be very much the same logic. Let's see. Let's see. Oh, let's keep that for a second. So what are we doing here? We've got an incoming message. If the incoming message, instead of saying key, what should we have done here? Oh yeah, that's all we know is that we've got a user. Okay, that's fine. So if incoming message says encrypted, right? Or if it says it's not encrypted, we could just do that. Agreed?
Yep.
Okay.
If in message is not encrypted.
Yeah. Everything is.
So if it's.
Yeah, I'm going to do the following here. Okay. Now.
That wouldn't be the default value of encrypted though, right? As being false. That would be.
So this is the thing here. Now we're going to do the decrypt. And the decrypt uses app.private key with the message, which, I did that just to make life easy. And if that fails, then we're doing this. So, and this is not encrypted data. This is what? No, but we've got to put it back inside the incoming message. So if that's decrypted data, string.
I'm a little confused on line 309.
All right, let me fish this and then we'll look at it.
All right.
Herbert keeps trying to join our session. Can you
just don't, because they're running a.
No, I'm not accepting it. I'm just telling you.
Yeah.
Okay. And then everything else would be process commands. So let's read this code. We know it's not a command.
Yep.
If the data is not encrypted, then just return the incoming message back, right?
Yeah.
If it is encrypted, then we got to use our private key to decrypt the message. and then we update the message with that information in it.
Where I'm getting confused is, isn't the default value of encrypted, isn't it? It's false.
Yep.
So on line 309, if we're saying not in message encrypted, wouldn't that mean that it's true, which would mean it
If
is
it's
encrypted?
no, if it's not encrypted, then there's no reason to run line 313.
No, yeah, I get that, but wouldn't the value of in message dot encrypted, if it was false, the opposite of that is true? So like, so wouldn't 313 be inside of that if?
No, I don't ever want to do that. That's harder to read. Look at the line of sight we've got here. So read this. What does this say in English? Forget about syntax. What does this say in English?
Yeah, if in message is not encrypted.
Then don't do anything. Just return it. We're done.
Got it. So that's my thing, is how do we know that encrypted is like true there or false? Like if it's the default value, that would mean
the
it's
default
true.
value is that encrypted is false. The default value is that nothing's encrypted. But one has nothing to do with the other here. This logic just says if data is not encrypted, we don't do anything. How
Okay.
that is said or not said is irrelevant to this line of code.
Got it.
Right?
Okay.
Completely irrelevant to this line of code. Now, if that flag should be true and it's not, that's an application level bug somewhere else. But
Got it. Okay.
we just received a message, right, from CAP, and that's it. So this is much better line of sight than putting this logic inside the if. We really want if statements to handle negative logic in a sense. So we can maintain these lines of sight. That's why I don't like else clauses. This is why every time I see an else clause, I panic, because it causes your brain to do bad things, at least my brain. So let's see here. This is the same. Oh, I forgot to do a false here. All right. So I think if we did everything right, we're now handling the encryption decryption piece of this. We will, from a CAP perspective, we've added the encrypted to both incoming and outgoing, right? Let's look at the changes real quick. On the CAP side, this is the CAP side. We've added encryption to the data models here. And we renamed that, but now we just renamed that. We renamed that. And then here we're adding encrypted. Oh, and we passed the encrypted up, passing that through. Right. And we pass encrypted through, and we pass encrypted through on the send. Okay, so that's the CAP changes. On the client changes, we are essentially adding encrypted to the outgoing, adding encrypted to the incoming. Herbert's trying to join again.
Yeah.
We are passing the
Talking with Eric a
user to the preprocess. We added encrypted there. We're not using that data to do any signing. But this tells us whether or not we did encrypt the data. Then we've got a bunch of new code on pre-processing. So we've really isolated the changes to that one pre-processing place, which is really nice. We did add this function, which is a little inefficient. We can make that more efficient when we're done. So there isn't really a lot of code changes here, which is kind of cool. All right. Now, from a logging perspective, though, let's see something for a second. Let's talk about logging for a second. When messages are coming in and out, you see here, so here's listen client. This came in from the client. So I think what we're going to have to do is add encrypted in message encrypted here. It says Kevin is joining. Kevin, you're here already, aren't you? I lost Kevin. God, dude, I've never
There we
had
are.
so many technical problems. Why do you keep dropping, bro?
That one was me. I fat fingered Command Q, just putting my hand on my keyboard.
All right. So on the cap side, I'm adding the encrypted information. To the logs. So we'll see whether it was encrypted or not. On the client side, what we can't have is the encrypted message sort of showing. Did I just lose Kevin again? Oh man, it's a bummer. Let's see. I don't know, dude. I'm giving up today with tech issues. All right. Giving up with tech issues today. So what a horrible stream we have today. I really apologize to everybody for the, never had so many problems before. I've got one person from my company constantly trying to get into this stream for some crazy reason. And now I keep losing Kevin. Try again. All right, I'm just going to keep going. I don't know what's going on today with things here. I know I don't see it. Could not start interview session. Okay, Kevin, you can't join anymore for some reason. It's gone. So I'm going to finish this work. You're going to have to jump on the live stream. It won't accept it anymore. It won't accept you anymore. I don't know why. So I'm alone for the next hour with all of you. Apologize for all the technical problems here that we're having. Total nightmare. But let's go back through this real quick. So I need to make sure that when we're showing the screen, though, it's not the encrypted message. And I think that's not going to be the case now. So because I do the screen here. Let's see. Update nonce. Insert message. Ooh. So that's interesting. That is interesting. Insert message. Do we insert the encrypted message, and then when we read them back, we've got to de-encrypt them? Oh my God, I just added a whole bunch of fun. That's added a whole bunch of fun to this experience right here. But I think the good thing here is when we do the send message, pre-process, and then that's what's getting signed. So I think on the screen, we're going to see, I'm looking for where this is used now. Oh man, that's crazy talk. Okay, pre-process the message, format, insert. Yeah. So we've got two things here we got to deal with that we're not 100% done yet. So when I hit the submit button, I find the user, I pre-process the message, it's now encrypted. We do the signing, we do that. But when I say insert, here, write to text. So right now what's going to happen, yeah, right now, sorry, man. What, pi. So we've got a few issues here. You see right here, I'm going to be logging or writing to the, here is fine, right? We're going to insert the encrypted message. But here I'm writing the not like the encrypted message too. And so, all right, here's message. Message gets the data the sign, message is the outgoing. Format message, you, fine. So the question is, do I want to encrypt what I'm writing to our file? And here we have to write the non-encrypted message. So if we're encrypting things, does it matter on my side that my logs show data that's encrypted or not? Man, probably that stuff should be encrypted in the logs, but that's going to cause some other problems. So we're not going to do that right away. But what this tells me at least is that if it's encrypted, I don't want a fourth parameter. Let's just go with that, okay? I don't want a fourth parameter. So maybe we do this instead. So everywhere that I had false, I turn that into an empty string. And then here I do message. So if I do that, then I'm going to get back both the regular message and the encrypted message, right? And if I do that, now what I could say here is, right, this is the, let's just call this the encrypted message just to do that. So var encrypted bool, if the encrypted message doesn't equal this, encrypted is true. Now that solves that problem. That's good. That's good. Right? That's good. Oh, but that means I want to use the encrypted message here. Okay. Oh. Oh, God. None of this is easy, dude. I need the encrypted. Okay, so let's do this. This is how we're going to solve it. Oh, I need the regular message, though. I can't just do that. Okay. Let's think about this, because I've got a couple of things here. We need to use the encrypted message here if, so this is the encrypted message. Let's do it this way. Encrypted message. I don't know what to call this. So, and these variable names are way too long, but it's okay. So I've got an encrypted message and I've got the, I don't want to call it message, just so bear with me for a second. So I've got that, right? And then the question for me is, this is the idea right now in my head. I need to set that message. So what I can do actually is better this way. I could say the message starts out this way, else the message starts out, gets converted to that. And we were already using the message itself. Okay, so the message changes. Yeah, we have to use this. Okay, so here's the idea. We use the non-encrypted message, but if we do have an encrypted message, we'll switch that out. Now, what will be nice about that is this will now use the right encrypted, not encrypted. This will use the right encrypted, not encrypted. We'll marshal that out and write it. We'll do our nonce. And right now we said we would do this because we're not going to play games. So we're going to use the non-encrypted message, insert that into there, and then write that. So I'm going to change that when we're done. But yeah, update the nonce, and then we do that. I almost feel like now this stuff is sort of all together here in a better block. So we update the nonce, and then right now we'll use the non-encrypted message to write to our logs and to write to the text. Ideally, though, we probably should use the encrypted, and then when we read it back up at the beginning, do all that decryption. But I just want to see a message going back and forth that's been that. So I think this works now. I think we're good. This works. And that's on the send side. Okay. Now on the receive side, which is going to be this, we read it, incoming query, update the nonce, process the message. Now this comes back. We're going to do the same thing here, I think. Because I think I need both. I think this is bad. I think we still might need both. So we might want to change this API right now to be more like the other one here. Where is it? Here. Let me see what happens if we do this for a minute. Okay, where we've got the non-encrypted and the encrypted here. So if it's not encrypted, what if we just did message, did that again? Okay, for consistency, right? If that failed, then you're going to have this and this, right? Just like we did down here. Fine. Now we've basically decrypted it. So you've got, remember, this is always the de-encrypted, encrypted. So I'm going to use the same language as I used before, right? Encrypted, de-encrypted. So I come back here, and this is really the de-encrypted data. There it is. Actually, we just do this. Sorry. De-encrypted in message is the encrypted. And then nil. So de-encrypted, encrypted, de-encrypted, encrypted. And then here, these are just commands, right? So I can just do this, do this, do this. Okay. De-encrypted. So this. Okay. And again, dot message. But this is now the message that we want to send, actually. So do that instead of updating our copy. So the idea now is that decrypted, encrypted, error. Decrypted, encrypted, sort of error. So we have both. And if that, then we don't have it encrypted. So if we come back here under pre-process, non-encrypted, I want to rename this to decrypted, just for that. So I think what we want to do is this again up here. Okay, take a look at what happens here. What did I do if this failed? Pre-process message error with nothing else. Yeah. I think we're just going to do the same right now. Preprocess message. Oh, but we have to write it. All right, preprocess. So what is the string I used here? Just preprocess message with the error. That's fine. Just do the same thing. All right. Now, I've got potentially decrypted and encrypted here. When it comes to all of this, remember this is the message that came in. Ideally, we want to see the decrypted here. And we want to see the formatted there. So we're not using this just yet, but I think we might need to for the insert at some point. So, write text from, what is it complaining about? sprintf does not support, you're right, it has to be an S. Okay, so even though we're not going to use the encrypted message, we'll use the decrypted one. Okay. Preprocess, I just want to look at this again. Nothing's encrypted, it was encrypted, now you get the decrypted, and you get the original message there, and everything else. Okay, so I think it's worth trying. Now, the problem now is I need Kevin to sort of help me, and Kevin is no longer on this chat. So I might ask Kevin, try to connect again, because sort of without Kevin being a guest, this gets really hard to test. And I need to be able to communicate. We've got like a 30-second delay. So can you try again, Kevin? Just try, dude. Let's try to connect one more time. Let's see what happens. And I don't know if I can clear all that. Copy the link. I'm going to give Kevin another link to try and join. Oh, interview. Now I know how to get to this screen. Interesting. Let me see if I can get Kevin one more time to... it says Herbert is joining. It says Herbert is joining. Now it says Kevin is joining. Could not start the interview session. Please contact support. Another session already active. So it thinks... Okay. So just to talk about this one more time, it thinks that we already have an active session. Oh, and we do. Oh, now you're back, dude.
Oh.
Now you're back. It
We are.
thought we had an active
Okay.
session. Maybe Herbert just finished his thing. There you are.
I'm not.
Oh. All right, I know what's happening now. We've got another stream going on at the same time, and we can only have the one guest, so I know what's happening now. Okay. So, note to self, we cannot have two streams happening at the same time where there is a guest. Okay, so can't have two streams happening with a guest. That's the problem. So we're got to know that for later. And Herbert can't stop what he's doing, but I guess Herbert got dropped as soon as Kevin came in. So there we go. So all Ardan streams today are in massive chaos. I guess we learned the hard way. All right. So Kevin, I'm going to push this code up. I'm going to push the code up, and we're going to have to try to test this. Now, we're not going to be encrypting messages at the logging at our database level, but let's see. So git status, git commit minus -am. Okay. So encryption messaging, let's see. Git push. All right, so Kevin, I'm going to do a make run cap. And Eric's got to tell, can you tell Eric he keeps trying to join mine? All right. So we've run the cap. I'm going to do a make run client. All right. Now Kevin, who I can only talk to over messaging right now. Kevin, pull the latest and run everything. All of this data probably should be encrypted. So if I go back to the code here, at the end of the day, I think these messages in here should be encrypted, right? Like if we're doing this right. But let's sort of run everything here. All right, now Kevin's going to send a testing message. Let's see what happens. And he's saying that stuff failed on his side. So I'm going to try to send something here then to Kevin and see what my logs look like. This is really hard today. Oh, it was on the wrong screen. All right, let's try again. So testing message. Okay, so I see some errors here. I see a bunch of bad stuff here. Oh, I see a bunch of bad stuff here. So, unable to read public key. So, I was a little worried that the function I was using to read the public key would be sort of bad. So, let's take a look at that code, because you got to use the right functions here or we've got problems. So, preprocess unable to read public key. Yeah, I was a little worried about this. So what we might need to do, okay, but this is, I can fix this one. That's not a problem. It would help if I could validate. So we know that it's not in. Okay, so then my guess here is, I've come in here, that this might not be exactly what we need. Unable to read public key. Would have been nice, Bill, if you also logged exactly what part of that it happened with, which I didn't do, right? Like this would have been better, right? So let me do that. This is client front end stuff. So I'm going to kill this. I'm going to run the client again. I'm going to say testing. I also don't like what happened on the screen with all that, but this is better. Okay, failed to parse public key. Use. Well, that was nice. It told me what function to use. I was worried about that. So that's easy then. Said use parse PKIX public key instead for this key format. Now that returned an any. And so here now we're just going to say a star to an RSA public key. Good. Yeah, I thought about that. Now, what I don't like though is, why did all this happen when I hit enter? So we got to go back to that too. So send message, boom, 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 pre-process. We saw error sending message pre-process, but I guess after we sent the message handler, after that got called, which is called by the UI, we did a bunch of really bad things too. So button handler, set text area, text. Right text, message. Yeah, I don't know why all this happened. So let me run the client again. Oh, that was already in there. But you could see that I read a line at a time. So probably what we want to not do in these messages is write this public key. So we'll fix that. I'll fix that too today, but that's what's causing that. So I have a problem where I'm not, after we write, we're not zooming all the way down. That's why I got confused. Okay, let me try this now. Kevin, I'm gonna save this code now. Fixing public key call. I was using the wrong one, right? We also have to fix the scroll, which is why I was so confused, but I'll do that in a second. Oh, make run client. So Kevin, I'm going to send you a message now. Make sure you're running the latest sort of client. In fact, send me a text message letting me know that you've got latest and you're running it. Okay, he said he's ready. So I'm going to write now testing again. Now, this was kind of cool, right? We saw this craziness in the logs. We probably should put encrypted message in the logs there so we don't see that at all. But Kevin, did you get that back and did you see it right? You saw nothing. Okay, that's fair. Oh, look, signature does not match. Okay, that's why you didn't see anything. So let's double check what's going on signature-wise with this encrypted data. We might have to send the data maybe as a slice of bytes right now. So we're managing it at a byte level instead of a string level because some things could be off. So let's do the following. We didn't say, hey, I never promised this was going to be easy. But you didn't see it, so I've got problems there. So let's double check again the whole send and the signature stuff. All right, so it looks like that we are signing the encrypted data, right? Where the encrypted data is a string, and we're sort of doing the conversion of bytes to string. So I think what we're going to have to do is change this to just raw bytes, and that way we don't have these sort of changes in interpretation or whatever's going over the wire, right? So let's go back and let's sort of make that change. So if I come back here, the message, if we switch it to a slice of bytes, and the incoming message is a slice of bytes, that I think will help some of our problem. Then I think we're going to come in here, and if I go to pre-processing message, change this to a slice of bytes, this to bytes, this to bytes. Then what's sort of nice is that can be nil. All of this, I got messages, yeah. That could be nil, that can be nil, that can be nil, that can be nil. Nil. All right, let's see what else we're doing now. The encrypted data then is already a slice of bytes, right? So all that is sort of clean. In fact, this doesn't even have to be converted anymore, right? That's kind of clean. Now, we were doing trim spacing, and so now all this is going to have to be string-based, right? So what we can do then is just come in here and say message string maybe. Or I don't know if the bytes package has anything like this. No. Let's just do it right now where I know where we are. So Just give me a string. We can look at the efficiency of that in a little bit. Okay. Now, at the end of the day, everything has to come back as a slice of bytes. Again, there may be better ways to do this, but we don't have to solve that problem right now. Okay. So that solves those issues. Now, this message, which is the send message handler, the message that comes in, we could change. Now, do we change that to a slice of bytes, or do we just manage that appropriately? So let's see what happens if I change this to a slice of bytes. All right. If the encrypted message doesn't equal nil, then that's good. This we're going to make a slice of bytes. That's good. All that is going to be good. Now, on the format message, decrypted message, right? The format message, we could also have it take a slice of bytes. It's fine. I wonder if I say string here, probably we'll just do the conversion. So we'll find out from that already. So that's good. But it has to return a slice of bytes at that point, doesn't it? Again, I'm sure there's a better way to do this. I don't know, but I want to deal with that right now. Insert a message. Okay, so now our interface is going to have to work with a slice of bytes. Man, this breaks everything. But no, everything else, it's just the one message. Insert message. Okay, that's fair. It's just the one message. That's fine. So insert contact, insert message, given a slice of bytes. This is going to help us anyway on the encrypted side, I think. messages. Let's take a look at that. Come back here. Yeah. Go to the definition of that. And so we make that a slice of bytes, right? At the app layer, it's a slice of bytes. That's fine. Let's see what else sort of breaks back here now. Then all that is good because that's a slice of bytes. Then flushing to disk has to be a slice of bytes. So let's go there. Your message is now a slice of bytes. There you go. I'm gonna delete our chat history to make all this work now too. Now we got write string. So we could still write it as a string, or we could just do a write. Now I still need the delimiter is the problem. But if I just did write there, I don't know. Let's just do this for now. Again, I'm trying to get to a point where this is going to work again. So that would handle this. And then on this side here, messages equals messages. So what was I trying to do here before? Query contact ID. Get the contact. Is there a set of messages? Read the messages from disk. And then this should have been a slice of bytes, but this is not right. So if we read messages off of disk, that's what we should be getting back. This can still be nil. And then this is going to be a slice of bytes. And then we're going to do a scanner. We're going to read. Now, I wonder if this is read bytes. Beautiful, right? And then we can append. Now all that is sort of good. Okay, so that gives us what we needed there. Going back to reading messages. Okay. Now, we're going to have problems here because when we say format the message, this has to use slices of bytes now. What time is it? I got to look at the time. And this has to use a slice. So we should have used these slices to begin with. You know, I originally thought about this, and, you know, I just wanted to get things working at first. So I sort of stayed in this direction, but now I'm wishing that I had just eaten that up the first time. But what's nice now is once we're done with this change, everything will be that. Now, for this again, I can just do what I did before on this side. So do this, then you got that, then you got that. I must have done that here too, maybe not. And then again, I think there's a better way to do this, but I'm don't want to deal with that right now. And then we've got this. So that takes care of that. Write to text takes a string. That's app UI write to text. And honestly, that should now take a byte slice. That's going to break the UI part a little bit because write to text. Now let's take a slice of bytes. And we'll deal with that here. So the message, right, text view, the message. I might just do this right now because I don't know what else to do there. And just to deal with that right now. And it complains here because write to text needs to be a, again, I think there's a better way to do this, but it's going to work for me right now. Okay, that takes care of you. Now we have all this write text. See, this is a bummer, right? Because I'm trying to write these error messages out. And I know there's a bytes package, but I don't think the bytes package has a like a formatter. You know what I'm saying? So I don't like this. And we could have just made this this API take a string, but I don't think that was the right thing to do. And I'm going to have to sort of look at how we can better do all this that I'm doing, you know. So I can send that as a slice of bytes. I don't think I've ever run into this before. And maybe we need a little function that can sort of clean this code up. So we're going to need another day to sort of clean up some of this sort of mess that I just created. Now, this is going to complain because we have and we want. So let's go back to our interface. And what was it again? It was on the send message handler. Send message handler. Update context. Send message handler. Whoa. Which interface is this looking for? A set app takes a app, a new app. Cannot use app as 2e app value in set. Oh. It's another interface here. Send message. Byte. Okay. So if that's the case, send message handler wants a slice of bytes. We get text. I'm just going to do this again. Oh, this is something we're going to have to review. Okay. I'm all yellow again. So we've got to make changes now on this side here because this is no longer a string. It's a slice of bytes. And the outgoing message is a slice of bytes. Okay. So let's see what breaks now when we do this. This in message was a slice of bytes. This now has to be a slice, a byte. Okay. Let's see. Send message client encrypted. This now needs to take a slice of bytes. Outgoing message, good. And this has to be a slice of byte. Okay. So I think that takes care of that. This should take care of our signature problem, though we might have some issues displaying things now. So what I'm going to do is, before I push any of this code, before I have to deal with Kevin, I already saw the error here on the signature, right? So, I'm also going to do the following. Do I care about deleting all that? Maybe not. I think that's fine for now. Make client. Make run client. Okay, so this was one thing I was worried about, right? I'm now just printing out the bytes there. And that's because I was wondering if the %s on that call here was going to take care of it, and it didn't. So we're going to do this for now. Oh, that was the wrong thing, I guess. Let's take a look at that. That should have turned it into a string return. Oh, is there a quick fix for this? Append f. Oh, shoot, look at that. Fump.append f. So we know how to fix all that other code now. It does that. However, I think what's really happening is wherever we're calling format message, maybe format message should return a string. Oh, but I don't think it can. Let's see where it's being used. Yeah, this is kind of cool. That will be a quick sort of fix for that. If I see it, I'll just do it. Now, yeah, write text took a slice. So I think that's what we're going to have to fix is the write text, which is on the UI side. Oh, I thought I did that. Look, fumped line, convert to string. Did I miss one of them? Oh. System UI ID dash. That's weird, man. With the brackets too. So, all right, this has me a little puzzled. So, this has me very puzzled. In order to write to that screen, we have to go through this function, don't we? Hello, Bill. God, I'm just having a bad day, man. I guess it happens. Gotta deal with that. Okay, so my guess is this is at startup. Let's go right back to startup here. Handshake, receive cat messages, main, app, TUI, new app, set app. Remember set app is supposed to do a bunch of stuff like supposed to cause the event that we have here to run. And we have a, okay, here it is, dude. Here it is. That's why that little code didn't convert to string. All right, man, I was going crazy there. Okay. Now, I just want to see that we're able to do a signature again. If not, then I definitely broke something. Testing sig. Okay, so now you can see that by switching to bytes, we've now got our signature stuff sort of working again. Okay, so I'm going to do the following. Escape, I'm going to kill you. Git status, I'm going to git commit -m fixed sort of sig stuff. We got to make sure that the stuff still works. So Kevin, I'm going to do the following. Before you, oh man, I didn't save anything. Hold on, we got to do it again. Before you do anything, Kevin, what we need to do, I think, is I'm going to get rid of the messages, go into your data, okay? Get rid of the key and bring everything back to 0. Okay? So get rid of the key, bring everything back to 0, and then you can run cap. Got like 15 minutes left today with all the chaos that we've had, and run client. So, all right, so I'm just leaving you a message, just left instructions. I'm sending Kevin a message over iMessage. We're going to remove existing messages and reset the database. So no key, and the nonces are 0. So hopefully Kevin sees that. If not, I really feel bad about this stream today. We tried to do 2 of these at the same time. The marketing team isn't going to be able to schedule anything during this again. All right, so I just saw a message from Kevin. It said testing. Hi, Kevin. And I want to know if Kevin got it back. So Kevin, did you get? Yep, hey, I got it. Okay, so now, Kevin, I'm going to try the share key. I got to get that out of our logs because that's bad. But share key. You share the key with, share your key. Okay, do the following anyway until we fix this. Take this out because we expect this to be a sort of single carriage return line feed. So I'm just going to take that out of your message bus until we fix that. Okay, now we've got encryption. Encryption should be set. So I'm going to send you something. Testing first. Encrypted message. I like that it said testing first encrypted message there. I don't know if you got that, but why don't you send me something back, even if you didn't, and then I can see what my logs look like. So, all right, so send me a message. Next message. So I got next message from Kevin. I've got a logging issue going on there. It did say encrypted, so that's cool. I do see the message in the encrypted form. I like that too, didn't have any, because now it is in the bytes like that. Yeah, so we'll have to deal with some logging there, but. And then actually, I guess even though it's a /n, it treated it just like bytes. So yeah, I mean, it worked by some miracle. It worked. The thing now is we really want to write the encrypted message to our log here, right? And then read them back up. So there it is again. That's your encrypted message. And thanks to the way that I guess we're logging that with bytes, it doesn't like go crazy there. So let's do the following now. Let's fix a couple things. Let's not write the key when we share keys. So that's going to be under preprocess send, share key. Oh, everywhere I see this too, I'm going to fix it because that's nice. And then, yeah, append F key, the public key. So let me see where this is used. Preprocess send, outgoing. So I feel like we don't want to do this if we know that it's a sort of command, right? We don't want to do that if it's a command, because we're seeing this there. So the question then is, I hate when this stuff gets sort of like this, but yeah, it's almost like if decrypted message doesn't equal that, then do these things. I think that will solve that problem. The next thing was, okay, the next thing then is writing the encrypted message on the insert. So what I want to do is sort of that. But I need the U, don't I? Like format message. Or I lose the U, and that's what we wanted to add. And the format message is kind of silly because it's just a, yeah, but it was a consistency with it, wasn't it? So I wonder, just do it twice. And we write that there, and we write that there, right? So we're going to insert encrypted messages to our log. Now, what that's going to mean is that we've got to de-encrypt them when we're sort of loading everything up. But I'm just curious what that looks like right now. So I'm going to go and delete this file again. All right. I'm going to delete that file again. But Kevin, I'm not going to push this just yet. I'm just going to run the client. So Kevin, send me another message. Send me a message. All right. We've got 8 more minutes here to play. So Kevin, send me another message. I just want to look at what that log looks like. Once you do that, let's see. All right, I might have lost Kevin again. So I like where we're at. Switching all that to bytes was good. Okay, got another message in. I'm hoping that what we see here, if I can get my cursor in the right place. No, so I still didn't do something right because this wrote another message. And I thought, oh, but this was on the send side. I didn't do this on the receive side. So hold on here. Let's see something. Pre-process receive message. Okay. This was on the send message side, but this is the receive message cap side. Okay. So essentially, if I'm looking at this right again, anything that comes in, right? Read incoming, nonce, update nonce, pre-process receive message, insert. Okay. Question. Oh, we're good there because we just write that back. Okay, sweet. So if we do the same thing, we look for the slash, right? So on the decrypted message, if it's not that, I'm just going to steal all this. Now I need encrypted message here. Then we're going to use the decrypted message here. I'm going to use the encrypted message here. I'm going to use the decrypted message here. Okay. Let me try that. I'm going to clear that out again. All right, we're going to try one more time, Kevin. It's the last thing I can do today. So, Kevin, send a message again. Okay, a message again. Please be encrypted. Cool. Okay. Now it's encrypted in here. Nobody can see it. Or if they see it, they don't know. Even the U could have been encrypted, but for now, that's fine. That's fine. But we're adding U there anyway, so. Okay, so right now the problem's going to be, and I just don't have any time, is that when we, on the UI side, see, when we read these messages line by line, we display that as a string, right? We now got to know if it's decrypted. We got to know if it's encrypted or decrypted and then sort of do that right. So we're going to need to change this a little bit to also let us know if it's encrypted or not. But I'm totally out of time here. So what we're going to do is I'm going to save this work. All right, let me add some notes here. I'm going to save this work. So keep everything here. Okay, so we have the encryption working. We are writing encrypted messages to disk, but we need to decrypt from disk on startup. And we need some sort of marker to know. All right, so that gives us that. So maybe, Kevin, we were going to schedule Delaney for Tuesday. Let's see if we could push it till Thursday. We need to get this done. I don't think there's a lot to do there. We're basically very close now. It's just a little bit of work. This took like 2 hours today to get where we're at. But we do have encryption, which is like brilliant. Everywhere that I have this, I've got to sort of clean up that code. Like the quick fix. You want to open, no. Or is it quick fix? Replace. So essentially, just kind of going through here. And I didn't know that off the top of my head. I think that's something that's fairly new. Fump depend F. That all worked with that. Nice, 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 nice. I think if I search for something like that, yeah, that's another one we can fix. And that was the last one there. And I might just search the entire project for that one. So we can fix that. Fix that. Fix that. Fix that. I fix these two. Nice. Like this type of tooling is so nice. I just show you a better way to do it. And then it works. Let's close all these files. Save, 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 save. Beautiful. Okay, we've got our notes. So I'm gonna shut all this down, get stat. I had a really bad stream today. Get commit -am, so we have some in encryption working, but need to handle our database now. Get push. Got that there. Again, I can't say it enough, but we've learned that we can't try to do multiple streams with guests coming in because bad things happen on the eCam side. So we won't do that again. But we do have encryption. We can share a public key. We can encrypt. We see it in the logs. We see it back. We've got to do some local database work. We'll do that next week on Tuesday. And then we'll try to bring Delaney in on Thursday to build a new client. But at least we have this client working 100% before we bring him in. We've got to fix that database stuff. Kevin will be here, hopefully live, so we don't have those issues either. And I hope you got something out of today. Again, I think the big thing was the mixing of concerns. We started maybe mixing a concern in the data store that we shouldn't have. We need to do some more code review. But all right, that's going to be it for today. Appreciate everybody sort of hanging out.